All right, let's work another example here. R equals 1 minus cosine theta. We want rectangular coordinates instead of polar coordinates. So again, we're going to try to manufacture this stuff. Okay, so if we've got r squared, we can substitute that. So that looks like that. And now I've got cosine theta. So I need to get something with r cosine theta. I think our original, or excuse me, the initial knee-jerk reaction here I would maybe be to square both sides. So, right, and we can think about what would happen there just a little bit, like if I squared both sides, right? So we can do that. And this side, we can get one step into this and kind of see where we're going. So if I square that, right, it's binomial squared. So we got the first thing squared plus 2 times the product of both of these, 1 and negative cosine. So there you go. And then the square of that one plus the square of that one. So cosine square theta. Okay, so we got r squared. That was good. But now what do we do with this stuff? I still kind of deepened my problem now because I don't have cosine squared over there. I need r cosine theta. So that might be a moment to say, well, maybe I should think of something else. So maybe scratch that and maybe come back to it later if what we do next doesn't work out, right? Productive struggle. All right. So let's try something else. R equals 1 minus cosine theta. Well, I want r squared, and I can square, we can get r squared. That's not a problem. What else can we do? We also need this. Well, if we multiply both sides by r, as long as r is not 0, this is a legal move, right? So maybe we should note that r is not or can't be 0. Right, so now we can come down here and say, okay, well now I've got r squared, that's great. And then we've got r minus r cosine theta. Excuse me. Okay, so now this guy is what, x, right? So that's good. And this guy is x squared plus y squared. That's wonderful. But we still have to deal with this, right? I need that to be either r squared or r cosine theta or r sine theta. Here's the trick. If we take and square both sides right now, we're going to end up with something ugly that we don't want, right? With pieces that we don't want. But if I take this and move it to the other side, like add it to both sides, right? Now we've got r square plus r cosine square equals r. And now if I square both sides, that's convenient looking, right? Because now I got r squared, and now I've got the square of convenient things. So this is x squared plus y squared. This is x, and now it's being squared. And now I've got r squared on the other side, so x squared plus y squared. So lo and behold, we've done it. So what we, we can't have r equals 0, so that, I think we talked about this in class, right? That corresponds to a point at the origin or the pole. So that's fine. R is not 0. But the other thing we have to worry about is squaring both sides, because that might generate us more things than we want. But I think maybe for the purposes of this video, it would suffice to be done at this point. There is, however, a wonderful explanation of why we ought to be wary of things like this in the textbook. Looking at it right now, it says page 929. So if you'd like to read about that, I would recommend you would do that. Anyway, that's it for this exercise. But maybe we should think about whether or not this shape is an easy thing to think about with algebra, because the last 2 examples sure were, right? We could graph something like this, and it might be, I don't know, illuminating for you to do that with maybe a graphing calculator or something. Because plotting points, this is not a standard shape, so plotting points would probably be not a great idea if we're going to try to draw a complete graph of this with all the good features. So anyway, maybe we could think about this on next time we meet in class, what that picture looks like. Because that's one of the topics for next week, if you would believe it. Anyway, that's it for the video. Have a nice rest of your day.